On a hot Saturday morning, while people are working inside, the air conditioner keeps the temperature inside the building at 23 degrees C. At noon, the air conditioner is turned off and the people go home. So it's kept at 23 degrees C all morning, and then at noon we change it. And so the interesting situation is what happens after noon. So noon is the starting time. Noon corresponds to t equals 0. Okay. And we need to do that here because look at the kind of questions they're asking. They're saying, what will the temperature be at 3 p.m.? So 3 p.m. will be t equals 3, because 3 p.m. is 3 hours after noon, and everything is in hours here. Look, the time constant is in hours. Okay. No, this is not the time constant. This is, they are saying, okay, this is the time constant. Time constant is 5 hours, right? All right. So, and then the other things, this is the initial temperature at noon, the initial temperature inside the building. So remember, the building temperature is the big T. So the big T at 0 equals 23. Okay. And then what else do we have? Temperature outside is a constant at 32 degrees C. So outside temperature is M. So M is 32. And then, so if it's constant at 32 degrees C, so additional heating rate due to people, lights, and machines. So they don't give us that, so we assume that that doesn't cause anything. Of course, people are gone, people go home, so there are no people anyways, but for the lights and machines, nothing is given, so we assume that U is equal to 0. And then, no, that's H. H is equal to H is the additional heating rate due to people, lights, and machines. And then U is the rate of change of temperature due to the furnace and AC. What will the temperature? The temperature outside is a constant 32. Okay, so the inside temperature will not change after noon because the air conditioner is turned off. So the rate of change of temperature due to furnace or AC is also 0. So U is also 0. Okay. And now we can use our Newton's law of cooling. So let's just rewrite it. Okay, so all right, we didn't take care of the time constant. So K, we know is 1 over time constant. So let's try. Insert equation. K is equal to 1 over the time constant, so 1 over 5. All right, so now we have everything. So let's just do it again. So now let's substitute the values. This would be 1 over 5. So this would be t over 5. And this will also be t over 5. This will be 1 over 5. And m is 32. So 32 over 5. And h and u are 0. And then when you integrate, okay, this is just outside the integration. And then 32 over 5 is a constant. And then the integral of e to the t over 5 is equal to e to the t over 5 divided by 1/5. So it'd be 5 times e to the t over 5. Plus c. And remember, this is distributing over all of it. So all right. So then once you distribute this e to the negative t over 5, you get, so this 5 and 5 cancels out. You get 32, and the e to the negative t over 5 cancels with the e to the t over 5. So it's just 32. And then plus c e to the negative t over 5. So that's t of t. And then we use the initial condition to find c. So the initial condition is t of 0 is 23. So let's substitute that. T of 0 and we are given that it's equal to 23. And so this is e to the 0, which is 1. So 32 plus c is equal to 23. So c will be negative 9. 23 minus 32. So c equals negative 9. Let me substitute that in here. Negative 9. Okay, so now the first part of the problem was what will be the temperature at 3 p.m. So at 3 p.m. little t is equal to 3. So you get t of 3. Negative 3 over 5. So now let's calculate it. 32 minus 9 e power negative. So 27.06. So the temperature is in centigrades. So 27.06. Okay. Nearest 10th will be 27.1. And then 6 p.m. is exactly the same. And then when will the temperature be 26? That's exactly like the previous question. Okay.